From sand to solid, a look at the worldwide production and manufacturing of glass. More than 100,000 tons of glass are produced worldwide every day. In the United States alone, annual glass production reaches 20 million tons. To meet this enormous demand, millions of tons of sand must be processed. But have you ever wondered how this fine powder is transformed into one of the most widely used solid materials in the world? In today's video, we'll see how glass is made from the fusion of silica sand. Stay with me until the end. I ask that you leave your like, subscribe, and activate the bell for all notifications. The world as we know it could not exist without it. This marvel of engineering is found virtually everywhere. It's an essential part of buildings, automobiles, smartphones, and even solar panels. Although it appears fragile, it can be surprisingly strong. When reinforced, it can withstand extreme temperatures, high pressures, and even violent impacts. Thanks to its incredible strength, glass is one of the most widely used materials in construction. Glass is believed to have been accidentally discovered by ancient peoples when they heated silica-rich sand with wood ash, which contains sodium carbonate. This mixture produced a substance that, when cooled, created a vitrified material. The first glass objects were made in ancient Egypt and Mesopotamia around 3000 before Christ. They were small items such as beads, amulets, and vases, usually colored and opaque. The Romans developed the glass-flowing technique around 50 BC, revolutionizing glass production and allowing the creation of larger, thinner objects in less time. During the Industrial Revolution, modern machines and furnaces enabled mass production. Flat glass, used in windows and mirrors, emerged. However, glass production was still a complicated and expensive process. Glass was manufactured in large furnaces and cast onto flat surfaces. However, the process was slow, inefficient, and did not produce perfectly flat glass. This required sanding and polishing, which significantly increased the final cost of the product. But everything began to change in 1952, when British engineer Sir Alastair Pilkington invented and developed a revolutionary method called float glass. This method allowed the continuous production of perfectly flat glass by floating molten glass on a surface of liquid tin. Thanks to this innovation, it was possible to produce completely smooth and transparent glass on a large scale and at low cost. The basic raw materials for glass manufacturing are silica sand, sodium carbonate, and limestone. Recycled glass colors can also be added. This dry mix is called a batch. Silica sand is obtained from natural deposits rich in quartz, such as riverbeds, dunes, and sedimentary rocks. After extraction, the sand undergoes a beneficiation process that includes washing, screening, and separation of impurities, resulting in a pure and uniform material. The washed sand and other raw materials are sent to glass factories. The largest industries receive up to 5,000 tons of silica sand weekly. The ingredients are stored in large silos and are collected as they need to be introduced into the production line. The ingredients are carefully measured and mixed before entering the furnace. Each component has a specific function in the glass-making process. Sand represents 60% of the composition and is mixed with sodium carbonate and limestone. These components modify the structure of the silica sand, helping to lower its melting point and allowing the mixture to melt more easily. While calcium carbonate serves to lower the melting temperature of the silica, limestone is used to improve the strength of the glass. Another essential ingredient is recycled glass cullet, which helps reduce energy consumption as it melts faster than virgin raw materials. This also reduces environmental impact and improves furnace performance. Other additives, such as iron oxide and cobalt, are responsible for the bluish coloration that characterizes certain types of glass. This mixture, once ready, is continuously fed into the melting furnace, where it is transformed into liquid glass. This large continuous kiln, made of refractory bricks, can operate 24 hours a day for 10 to 15 years without shutting down. The mixture enters from one side and is gradually heated until it reaches temperatures between 1,400 and 1,600 degrees Celsius. Inside the kiln, heating is typically done using natural gas. The ingredients melt, releasing gases and forming a homogeneous liquid mass. The liquid glass passes through a hotter zone to eliminate bubbles and impurities. The natural thermal agitation of the mass ensures a uniform glass composition and viscosity. Liquid glass at a high temperature, approximately 100 degrees Celsius, slowly flows over a bath of molten tin. This process occurs in a protected environment, filled with gases such as nitrogen and hydrogen, which prevent the tin from oxidizing. Due to the difference in density, the glass naturally floats on the tin, much like oil on water. Thanks to gravity and surface tension, the glass mass spreads evenly, forming a continuous, smooth sheet of uniform thickness. The final thickness can be controlled by the speed at which the glass advances and by using rollers at the edges. Tin is a metal that remains liquid at high temperatures. It does not mix with the glass and provides a perfectly flat, polished surface. When it leaves the tin chamber, the glass is already solid, but still very hot. It then enters a special tunnel called a layer, where it undergoes a gradual and controlled cooling process known as annealing. The glass enters the tunnel at approximately 600 degrees Celsius, passes through a slow and progressive cooling zone, and emerges at room temperature, completely stabilized. The cold glass travels along conveyor belts to be cut to the desired dimensions. Cutting is done by automatic machines using industrial diamond tips. Both the center and edges of the glass are scored with diamonds and then precisely broken along the cutting line. Sheets can be cut to standard or custom sizes. The entire process is monitored from a control room that monitors furnace temperature, glass quality, line speed, and each stage of production in real time, ensuring efficiency, safety, and high-quality standards. Flawed glass is rejected, shredded, and returned to the beginning of the production chain as recycled glass shards. Approved glass sheets are collected and stacked vertically on metal racks. They are separated with protective materials to prevent scratches and breakage, and are ready for packaging and distribution to the consumer market. In the artisanal glass making process, all production steps are carried out as manually as possible. Each part of the furnace houses molten glass of different colors, producing different glass sheets. Once the material is molten, the team works quickly, extracting the liquid glass from the furnaces with special ladles and quickly transporting it to the mixing table. It is important to keep the glass constantly moving to prevent premature cooling during the process. To create the blended pieces, up to 5 different colors of glass can be mixed. But before the glass is stretched into a sheet, the artisan uses a special type of graphite to mix the incandescent mass. The molten glass is then deposited into the roller machine, which presses and flattens the mass evenly as it passes between them. The distance between the rollers determines the thickness of the glass sheets. Once formed, the glass sheet is transferred to the annealing furnace, where it is gradually cooled to prevent the glass from breaking or cracking during cutting. Cutting is also done manually using a diamond-tipped or tungsten carbide cutter. And that's how more than 100,000 tons of glass are produced every day around the world. If you want to know how a big pen is made, check out the link in the description and in the first comment. If you like the video, please like it and share it with your friends. Leave a comment telling us where you're watching from and what you thought of this episode. Subscribe to our channel and turn on the notification bell to be notified whenever we publish new content. Thank you for sticking.